In section 5.3, we're going to look at the slope-intercept form of the line. We're going to find that lines can be written in lots of different formats. So, the first thing we want to look at is what is slope-intercept form. So, the linear equation, y equals mx plus b, is written in slope-intercept form, where m is the slope and b is the y-intercept. And this should be familiar to you from last year. So something like this, where we have y equals 3x plus 2. And since that's in y equals mx plus b form, we can see that m is 3 and b is 2, because the 3 falls in the position where m is, and the 2 falls in the position where b should be. So m is the slope, so 3 is my slope, and b is the y-intercept. So if I look at this and want to graph, we know how to graph the y-intercept. We put it on the y-axis. And the slope is our rise over run. So since I want to write that as a fraction, I'm going to write it as 3 over 1, because that's the same as 3. So if my rise is 3 from my y-intercept, I'm going to go up 3 units. Whoops, I shouldn't put a dot there. I'm going to go up 3 and then to the right 1, and that's where my ordered pair is going to go. So I'm going to connect those 2 points, and that should be the equation of my line. So slope-intercept form, from just looking at it, we can tell the slope and the y-intercept. So we want to learn how to write an equation in slope-intercept form if you're given the slope and the y-intercept. So very simply, if you're told that the slope is 3/2 and the y-intercept is 6, in other words, if m is 3/2 and b equals 6, again, since I want slope-intercept form, I'm going to use my model, and I'm going to plug the slope in for slope and the y-intercept in for b. And again, I can graph this if I want, starting with the y-intercept always, 1, 2, 3, 4, 5, up 6. Counting the slope from there, my rise is 3 and my run is 2. Now, it's a little hard to go up 3 from here because I'm off my graph. So I want to look at this. If my slope is 3 over 2, that's the same as negative 3 over negative 2, because a positive divided by a positive and a negative divided by a negative are both positive. So I can go down 3 and to the left 2, and that's the same as going up 3 and to the right 2. You can see that both of those points are on the same line. Look at this a little bit more in a minute. So writing an equation, if you are given the slope and the y-intercept, is just a matter of substitution into the model. Now, if we want to write an equation in slope-intercept form when we've been given 2 ordered pairs. So let's say I tell you that the point 0, -1, and the point 3, 4 are on a particular line. And I want to write an equation in slope-intercept form. So again, using y equals mx plus b. Well, from looking at this equation, I can tell when I plot 0, -1, that that's the y-intercept. So b is -1. So all I need to find is the slope. So using my formula, y minus y over x minus x, I will get 5 over 3. So now, using my model, the slope is 5/3 x, the y-intercept is -1. So -1, I've already plotted. I'm going to do my rise over run, up 5, 1, 2, 3, 4, 5, and to the right 3. And then if I connect those 2 points, that's my line. And take a look at what this point is. It's the point 3, 4. That's the one I started with. So that's pretty good evidence that I've done the equation properly and graphed it properly. So, given 2 ordered pairs, we use the 1 ordered pair that will be your y-intercept, and the other will help you find your slope. So, graphing an equation. We've already done this quite a bit, but we're going to do one more just to go over it. So if you are given an equation already in y-intercept form and you want to graph it, all we have to do is take a look at it. Y equals -2/3 x plus 1. Remember we said that first we're going to plot the y-intercept, which is our b value. Then we're going to count our slope, which is m, by using rise over run. And let me clarify, rise is our up and down direction, run is our right and left. So even though it says rise, if that top number is negative, we're going to go down. So let's look back at our equation. +1 is my y-intercept, and my slope is -2/3. So my rise, or my up and down direction, is down 2, and then I need to go +3. So down 2 to the right 3. Now keep in mind that -2/3 is the same as 2 over -3. So I could have gone up 2 and to the left 3. But if you notice, I still end up with points on the exact same line. Sorry, I didn't mean to do that. So I still end up with points on the exact same line. Okay? So down 2 and to the left, down 2 and to the right 3 to get to here is the same as going up 2 and to the left 3. Graphing an equation that's given in standard form. So sometimes we're going to see equations that look like this. If I want to graph this, I want to first of all change it to y equals mx plus b. So I want to isolate the y. So the first thing I'm going to do is subtract my 5x. So now I have -3y equals -5x plus 6. And then I have to divide by -3. And notice that I'm dividing every term by -3. So y equals -5 over -3 is the same as +5 over +3. 6 divided by -3 is -2. So now I'm ready to graph y-intercept at -2. Count my slope. My rise over run is up 5 and to the right 3. 1, 2, 3, 4, 5 to the right 3, and that is my graph. Now we did in the last section graph these a little differently. We looked at 5x minus 3y equals 6 and we used the x and y intercepts. The x-intercept here, remember the value of x when y is 0, was 5x equals 6 or x equals 6/5. Well, 6/5 is just a little bit more than 1, so that looks pretty good, but it would be hard to graph that if I didn't know for sure. The y-intercept, the value of y when x is 0, 5 times 0 minus 3y equals 6, and that is -2. So the first method is to change to y equals mx plus b form. The second method to graph this is to use the x and y intercepts. We get the same graph. X-intercept is 6/5, y-intercept is -2, or y-intercept is -2, and then count our rise over run. So 2 methods to graph an equation when it's given to you in this form. The last thing we want to look at is creating a slope-intercept equation from a word problem. So here's an example. The amount of natural sweeteners consumed has increased by an average of 2.6 pounds per year. Rate of change, or a change per year, this is a slope. Write a linear equation to find the average consumption of sweeteners in any year after 1988 if the amount of sweetener in 1989, if the amount of sweetener was 133 pounds. This is my beginning value. And a beginning value is the same as a y-intercept. So where do we start? That's what we're asking. So if I start at 133 pounds and I go up 2.6 every 1 year that I go to the right. So after 1 year, if I've increased by 2.6, I'm at 135.6. So starting here with my y-intercept, up 2.6 to the right 1. In the next year, I'm going to go up another 2.6. That would put me at 138.2. Okay, so each year I am increasing by 2.6 for each year. So what I want to do is make this beginning year, 1989, equals year 0. So 1990 would be year 1, etc., etc. So my slope again is 2.6. My x value, or my y-intercept, my b value was 133. So my equation will be y equals 2.6x plus 133. And to make this a little bit more useful, x is really the number of years. So I'm going to use a variable t instead of x, and y is my consumption of sugar. So I'm going to say consumption equals 2.6 times t plus 133. We'll look at this a little bit further in class, but that's all the notes you need. Make sure that you've watched this a couple of times and that you've taken and jotted down some questions for me.